Alright, this first video is really a basic overlook of matter and how exactly we categorize matter. I imagine that if you've already had a chemistry class, most of this is going to be review. However, there will be a little bit of a physics twist on it as we go further and further throughout the unit. So if we just take a look at this, right off the bat, matter, we're going to focus on the particle model of matter, which basically just says, okay, all objects are made of these small divisions called atoms, which you've been introduced to many times. Okay, now the thing that we have to remember with atoms, and this is going to come in handy when we actually start talking about the physics, is that atoms are to be considered very small, perfectly elastic balls. Now, we've just got done with momentum and energy, so we should know that the words perfectly elastic indicate that momentum and kinetic energy are conserved. Okay, so that's kind of a key part to this. Okay, so some basic definitions of things, which again I'm sure you're fairly aware of. Elements are made of one type of atom. Compounds are made of more than one type of atom. For example, compounds like water, H2O, there's both hydrogen and oxygen in there. You know, those are the things that we're talking about when we're differentiating between elements and compounds. Something else that comes in quite frequently is a mole. Again, if you don't remember what a mole is the measure of the numbers of atoms or molecules in any material. If you look up there, I've given you the number that you need to know. I believe it's in your packet. 1 mole, 6.022 times 10 to the 23rd atoms, often referred to as Avogadro's number. Just keep in mind that, you know, every mole does not have the same mass because each different type of atom has its own atomic mass. So, for example, one atom of carbon is listed as 12.011 AMU, whereas 1 mole of carbon is 12.011 grams. The same thing could be said for any other atom. Is if you look at the periodic table, they always give you an atomic mass. Well, that atomic mass would be the number of grams in 1 mole of that particular element. And if it was compound, you'd have to add up all the atomic masses, and then that would tell you how many grams are in 1 mole of that particular compound. Okay, we'll do some example problems with moles tomorrow. Okay, the last thing, and again, I'm sure this is, you know, a little elementary for most of you, but in states of matter, obviously I don't have plasma on here. We're not going to worry about that, but for now we're going to look at solids, liquids, and gases. Just keep in mind that solids are, you know, in a fixed shape and volume. They're held close together. They don't get to move around very much. If you have a liquid, obviously they can move around a lot more freely. Hence, it has no shape, but it does have a volume per se. And then a gas, you know, really doesn't have a fixed shape or volume. It basically expands to fill whatever container it's in. So we're going to consider the forces between those atoms to basically be zero, and that's ideally, of course. Okay, and so this is just a basic overview of matter. And then we'll go a little further with this as we move along in the unit. All right.